We were always told that when the dinosaurs ruled, the mammals hid in the dark and waited. Then we dug one up with a dinosaur still inside its stomach. And that is the tame one. These are 10 tiny prehistoric creatures that, by every rule we know, should never have existed. Alright, let's dive in. Number 10. HALLUCIGENIA, the animal nobody could draw right. Around 508 million years ago, in the warm Cambrian Sea, there crawled a creature so bizarre that it took science nearly 40 years just to figure out which way was up. It came out of the Burgess Shale, the famous rock formation high in the Canadian Rockies that preserves the soft bodies of the earliest complex animals in astonishing detail. And when the paleontologist Simon Conway Morris first reconstructed it in the 1970s, the result was so dreamlike and impossible that he named it HALLUCIGENIA after a hallucination. Here is how badly the first attempt went.
The animal is a tube, about the length of your thumbnail to your thumb, with rows of long, rigid spines down one side, and a row of soft, waving, tentacle-like limbs down the other. Conway Morris looked at this and made a reasonable guess that turned out to be exactly upside down. He decided the stiff spines were legs, a set of 7 rigid stilts the animal tiptoed around on, and that the soft, waving tentacles on top were some kind of feeding apparatus on its back. For years, that was the official HALLUCIGENIA, a creature walking on knives with a row of mouths on its spine. It gets worse, or better, depending on how much you enjoy science being humbled. They also had it backwards. There was a blob at one end that everyone assumed was the head. In 2015, a team led by Martin Smith and Jean-Bernard Caron took fresh specimens and powerful electron microscopes to the problem and discovered that the blob was not a head at all. It was decay fluid, gut contents that had squeezed out of the body as it rotted and fossilized, a stain that everyone had mistaken for a face. The real head was at the other end entirely, and when they finally found it, it was looking back at them. HALLUCIGENIA had a pair of simple eyes and a ring of teeth around a circular mouth, with yet more tiny teeth lining its throat. So the corrected animal is this. Flip the spines to the top, where they are armor, defending a soft body from predators. Put the tentacle legs on the bottom, where they are legs, tipped with tiny claws. Turn it around so the head with its eyes and ring of teeth faces forward. What you get is a member of an ancient group called the Lobopodians, soft-bodied, worm-like animals with legs, and the closest living things to them today are the velvet worms, the strange little predators that still hunt in tropical leaf litter. HALLUCIGENIA was not a hallucination after all.
It was a real, armored, clawed worm with a face full of teeth that simply did not resemble anything we expected an animal to look like. To understand why this one mattered so much, you have to understand where it came from. The Burgess Shale was discovered in 1909 by Charles Walcott, and it is one of the most precious fossil sites on Earth, a rare window that preserves not just shells and bones, but the soft bodies of animals from the Cambrian explosion, the great burst of evolution when almost every major group of animals first appeared, more than 500 million years ago. Most of the time, soft-bodied creatures rot away and leave nothing. Here, they were buried so fast by underwater mudslides that even their skin and guts survived as films in the rock. HALLUCIGENIA is one of the so-called weird wonders of that fauna, animals so unlike anything living that scientists genuinely struggled to fit them into the tree of life at all. The clue that finally cracked the puzzle came from China. In the Chengjiang deposits, a slightly older treasure trove of Cambrian fossils, paleontologists found close relatives of HALLUCIGENIA, preserved well enough to show that the legs came in pairs, which is what allowed researchers to confidently flip the animal the right way up. And when Smith and Caron examined the spines under powerful microscopes, they found they were built from stacked layers of cones, nested one inside another, like a set of Russian dolls. The exact same microscopic construction found in the claws and jaws of modern velvet worms. That tiny detail, hidden inside a spine, was one of the threads that tied this impossible animal firmly to a living group and turned a hallucination into a real branch of the family tree. As for how it made a living, the corrected anatomy finally lets us guess. With its ring of tiny teeth and a throat lined with still more, HALLUCIGENIA was probably a slow, deliberate feeder, creeping across the seabed or clambering over sponges and scavenging scraps, its armored spines warning off anything that might want to make a meal of the soft body beneath. It belonged to a whole radiation of these spined, legged worms that briefly flourished in the Cambrian seas, a design that has almost entirely vanished from the modern world, surviving only as the velvet worms hidden in tropical forests. The biologist Stephen Jay Gould made animals like this famous in his book on the Burgess Shale, using them to argue that if you rewound the tape of life and played it again, the survivors might be completely different, and creatures like HALLUCIGENIA might have inherited the Earth instead of us. Whether or not he was right, the point stands. There was nothing inevitable about which of these early experiments lived and which were erased.
The Chinese fossils that finally turned it the right way up belong to a slightly different species, HALLUCIGENIA fortis, from the Chengjiang beds, and they preserved the paired arrangement of the legs with a crushed Canadian specimens never had. Counting them is itself a small marvel. Rows of slender, clawed legs paired with the long defensive spines above, on a body no longer than a grain of rice in some individuals. Each of those claws, like the spines, was built from those nested layers of cuticle that point straight back to the velvet worms. For an animal once reconstructed as a row of stilts wearing tentacles on its spine, the final portrait is almost dignified. A tiny, deliberate, well-armored predator, or scavenger, of the Cambrian floor. Perfectly real, perfectly explicable, and still utterly unlike anything you could meet today.
That is the gentlest entry on this list. An animal so alien that the experts had it upside down and backwards for 4 decades, and it was completely harmless. The next creature broke a far bigger rule because it lived in the age of dinosaurs, and it ate them. Number 9, REPENOMAMUS, the mammal that hunted dinosaurs. For most of the last century, the story of mammals during the age of dinosaurs was a story of humiliation. The textbooks all told the same tale. While the dinosaurs ruled the day, mammals were tiny, timid, nocturnal things, shrew-sized creatures that scurried in the undergrowth, ate insects, and waited tens of millions of years for an asteroid to clear the way. Mammals were the meek, hiding in the dark. Then, from the rocks of Liaoning province in China, came a fossil that tore that story apart. The animal is REPENOMAMUS, and it lived around 125 million years ago, in the early Cretaceous. By the standards of Mesozoic mammals, it was a giant. The larger species reaching about the size of a badger or a small dog, perhaps a meter long and 12 to 14 kilograms, built low and powerful, with strong jaws. That alone was a surprise, but in 2005, a study published in the journal Nature revealed something that genuinely stunned paleontologists. They had found a REPENOMAMUS fossil with its last meal still preserved inside its ribcage, in the space where its stomach had been. And that meal was a dinosaur. Packed into its gut were the bitten-up, articulated bones of a juvenile Psittacosaurus, a small, beaked, plant-eating dinosaur. Here was direct, undeniable proof that a mammal had eaten a dinosaur, swallowing it in chunks. For years, that was the headline. Then, in 2023, it got even better. Scientists described another extraordinary fossil from the same region, and this one was not a meal. It was a fight.
Preserved in the rock were a REPENOMAMUS and a Psittacosaurus, larger than the mammal, locked together in combat at the instant they died. The mammal is on top, its body coiled, its teeth biting into the dinosaur's ribs, one paw gripping the larger animal's snout. The dinosaur is sprawled beneath it. The two were entombed together, mid-struggle, by a sudden flow of volcanic mud, a Cretaceous Pompeii that froze a predator and its larger prey in the act. The most likely reading is that this badger-sized mammal was attacking a dinosaur bigger than itself. The rock that produced this animal is one of the most remarkable fossil sites in the world. The Yishian Formation, part of what is called the J-hole biota, is another Pompeii-like deposit, where repeated volcanic eruptions buried entire ecosystems in fine ash, preserving them in breathtaking detail. This is the same formation that gave us the first unmistakable feathered dinosaurs, early birds, and flowering plants.
Within it, REPENOMAMUS stands out as a heavyweight. The larger of its two known species, REPENOMAMUS giganticus, reached around a meter in length and is one of the largest mammals known from the entire age of dinosaurs, with a powerful skull and teeth clearly built for tearing meat. The discovery did not just add one strange animal to the list, it helped overturn an entire chapter of the story of life. For decades, the assumption was that dinosaurs kept mammals permanently suppressed, locked into tiny, marginal roles for over 100 million years. But a wave of finds from these Chinese beds has revealed Mesozoic mammals that glided between trees, that swam with beaver-like tails, that dug burrows, and, in the case of REPENOMAMUS, that actively hunted dinosaurs. The combat fossil described in 2023 sharpened the point.
Some researchers had wondered whether the dinosaur in that first stomach was merely scavenged, but an animal locked in a grappling hold, biting a struggling dinosaur larger than itself, is very hard to explain as anything other than a predator caught in the act. The meek, hiding mammal of the old textbooks was, at least sometimes, the one doing the hunting. The wider haul from these Chinese beds has been almost comic in how thoroughly it dismantled the old picture. One Mesozoic mammal, Castorocauda, had a flat, scaly, beaver-like tail and webbed feet for swimming. Another, Velaticotherium, had a membrane of skin stretched between its limbs and glided between trees tens of millions of years before bats or flying squirrels. Others were specialized diggers. The Mesozoic, it turns out, was not a holding pen where mammals waited their turn. It was a world in which they were already quietly diversifying into swimmers, gliders, burrowers, and, in the case of REPENOMAMUS, armed predators bold enough to take on the young of the dominant reptiles. When the asteroid finally fell and the giant dinosaurs vanished, mammals did not start from scratch. They expanded from a running start that had been building in secret for over 100 million years. The specific beds that yielded the fighting pair, known as the Lujiatan beds, are sometimes called the Chinese Pompeii because of how violently and completely they buried their inhabitants, catching animals in lifelike postures in the moment of death. That is why the combat scene is so persuasive. The two animals were not jumbled together by a river or a scavenger, but frozen in place exactly as they fell.
Weighing the mammal against the dinosaur it gripped, researchers estimate REPENOMAMUS was taking on prey at or beyond its own body size, the kind of bold predation we associate with wolverines or honey badgers today. Whether every such encounter ended well for the mammal, we cannot say, but the fossil records at least one occasion when a creature the old textbooks called timid had a dinosaur by the ribs and was not letting go. This is why REPENOMAMUS should not, by the old rules, have existed. Everything we were taught said mammals spent the Mesozoic cowering. Instead, what we have is a stocky, aggressive, dinosaur-hunting predator, turning the supposed natural order on its head, in the middle of the dinosaur's own world. It did not wait for its turn, it bit back. From a dinosaur-hunting mammal, we go back to that same strange Cambrian sea, to an animal that watched the world through 5 eyes. Number 8. OPABINIA, the 5-eyed creature that made scientists laugh. Stay in the Burgess Shale, roughly 505 million years ago, because the Cambrian was not finished being strange. Among the animals preserved in that rock is one called OPABINIA, a soft-bodied swimmer about the length of your finger, and it has the distinction of being one of the only fossils in history to make a room full of serious scientists burst out laughing. It happened in 1972. The paleontologist Harry Whittington had been carefully studying OPABINIA, and he presented his reconstruction at a scientific meeting. When the image went up, the audience laughed out loud because nobody could believe it was real. Look at what he was describing. The animal had 5 eyes, not 2, mounted on stalks on top of its head, scanning in multiple directions at once. Running down its body were rows of overlapping flaps it used to swim. And at the front, where you would expect a face, it had a long, flexible, hose-like trunk, a soft tube reaching out ahead of the body, ending in a grasping claw lined with spines. This was not a creature that fed like anything alive today. The mouth was not at the end of the trunk, and was not even at the front. It was tucked underneath, facing backwards. So OPABINIA fed by reaching out with that long, flexible nozzle, seizing soft prey from the seabed with the claw at its tip, and then curling the trunk back and underneath to stuff the food into a mouth that pointed the wrong way. Picture an animal vacuuming the seafloor with a clawed elephant's trunk, watching everything through 5 stalked eyes while it did so. The audience laughed because it looked absurd, but it was absurd and real. That moment of laughter in 1972 was more important than it sounds, because it marked a turning point in how we understand early life.
Harry Whittington and his students were in the middle of re-examining the entire Burgess Shale, and what they kept finding was that these Cambrian animals were not simply primitive ancestors of modern groups, as everyone had assumed. Many of them were genuinely alien, experiments in body design that left no descendants at all. OPABINIA became the poster child for that idea. The animal that proved the early history of life was far stranger and more branching than a simple march toward the creatures we know. For decades, OPABINIA stood almost alone, a one-off so peculiar that scientists could barely classify it. Then, in 2022, researchers identified a second member of its group, an animal called Utarora, which had been sitting unrecognized in a museum collection for years. That find mattered because it confirmed OPABINIA was not a freak accident, but part of a real, if tiny, branch of the tree. A group sitting right at the origin of the arthropods.
The strange grasping proboscis at its front turns out to be a crucial clue in one of the biggest questions in animal evolution: how the specialized head and limbs of arthropods, the most successful animals on the planet, first came together. OPABINIA's ridiculous vacuum hose face is, in fact, one of the keys to understanding where insects and spiders ultimately came from. Look closely at how that body actually worked, because every part of it is a small shock. The 5 eyes are usually described as 2 pairs mounted close together, plus a 5th set slightly apart, all raised on short stalks, giving the animal an almost insect-like alertness 500 million years before insects existed. Down each side ran a series of overlapping blade-like flaps that rippled to push it through the water, and beneath those flaps lay structures that likely served as gills.
So OPABINIA swam by undulating a fringe of paddles, breathed through them, watched in every direction through 5 eyes, and fed with a flexible clawed hose. It reads like a creature assembled from mismatched parts, and in a sense it was. A transitional form, frozen at a moment when the arthropod body was still being negotiated, before evolution committed to the head, the legs, and the hard external skeleton that would go on to conquer the planet. Even the animal's formal name carries a hint of how regal its strangeness seemed to those who studied it. It was christened OPABINIA regalis, the regal one from Opabin, after a mountain pass near where the Burgess Shale is exposed. For the better part of a century, it stood essentially alone, a singular oddity with no known kin. which is why the 2022 recognition of a relative hidden in museum drawers was quietly thrilling for the people who study this period. It meant the five-eyed swimmer was a genuine lineage, however short-lived, and not just a single evolutionary hiccup. It remains one of the most important animals for understanding the deep origins of the most successful body plan on Earth, the arthropod, which today accounts for the overwhelming majority of all known animal species. OPABINIA matters for more than its strangeness. It belongs to a critical moment in evolution, a halfway form that sits between the soft, legged worms like HALLUCIGENIA and the great Cambrian superpredators, the radiodonts like the famous Anomalocaris. It is a snapshot of the arthropod body plan being assembled, piece by experimental piece, before evolution had settled on the design that would eventually produce every insect, crab, and spider on Earth. OPABINIA is what an early draft of that story looks like. 5 eyes, a vacuum hose, and a face that no animal before or since has ever worn. From this 500-million-year-old sea, we jump forward in time to a Cretaceous forest and an ant that drank blood. Number 7. The hell ant, an insect built upside down. About 99 million years ago, in a steamy forest where dinosaurs still walked, a drop of sticky tree resin fell onto a tiny hunter in the middle of a kill and froze the entire scene. That resin became amber, and that amber, found in Myanmar, preserved one of the most alien insects that has ever existed. Scientists call them hell ants, and although they were genuinely ants, they were ants like nothing alive today. Every ant you have ever seen has jaws that open and close sideways, swinging horizontally like a pair of pincers. Hell ants did not. Their long, scythe-shaped jaws hinged the other way, swinging vertically, upward, toward the top of the head. And rising from the ant's forehead, right where those jaws closed, was a horn. The whole arrangement worked like a bear trap mounted on a face. When prey brushed against the trigger hairs, the scythe jaws snapped upward and pinned the victim against the horn, impaling or clamping it in place. In 2020, researchers led by Philip Barden described an amber fossil that caught this in the act. A hell ant gripping an extinct cockroach relative exactly that way, its jaws curled up around the prey against its horn. It confirmed what scientists had long suspected but never seen. These jaws moved in a direction no living ant's jaws can move. And then there is the blood. One species, discovered in 2017, was named Lingua myrmex vladi, after Vlad the Impaler, the historical inspiration for Dracula. Its horn was not just bone. It appears to have been reinforced with metal, strengthened with minerals to take the impact of the strike, a built-in anvil for impaling prey. Researchers think it used that horn to pin victims and feed on their hemolymph, the internal fluid that serves as insect blood. A metal-horned, blood-feeding ant. Some hell ants had jaws so wildly specialized that they could not even feed themselves with them. Instead, like the so-called Dracula ants that still live in Madagascar today, the adults likely fed captured prey to their grub-like larvae and drank fluids in turn. The substance that preserved these ants is a story in itself. Burmese amber, from the Hukong Valley in northern Myanmar, is a roughly 99-million-year-old window into a Cretaceous forest, and it has produced some of the most spectacular fossils of the last 2 decades, from feathered dinosaur tails to frogs to entire scenes of predator and prey frozen mid-action. The detail is so fine that researchers can study the individual hairs on an insect's leg. It is also amber that comes with serious ethical questions tied to conflict in the region, which is why much of the scientific community now treats new specimens with great caution. What the amber reveals is a group of insects running a wild evolutionary experiment. Across the 16 known species of hell ant, the horns come in a startling variety of shapes, some broad and paddle-like, some narrow spikes,
each apparently tuned to a different style of catching prey against those upswinging jaws. Philip Barden has argued that the jaw and the horn evolved together as a single integrated unit, an innovation that opened up a whole new way of hunting, much as the linked bones of the vertebrate skull once did for animals with backbones. And yet, for all that ingenuity, the hell ants died out completely at the end of the Cretaceous, while the ordinary horizontal-jawed ants they lived alongside went on to become one of the most successful groups of animals on Earth. The strangest design did not win. The ordinary one did. The contrast with living ants makes the hell ant even stranger. A few modern ants, the trapjaw ants, have independently evolved spring-loaded jaws that snap shut with some of the fastest movements in the entire animal kingdom, fast enough to fling the ant into the air. But those jaws still close horizontally, side to side, the way all living ant jaws do.
The hell ants are the only ants we know of that broke that plan entirely and hinged their mouths to strike upward against the head. And the comparison to today's Dracula ants of Madagascar is telling. In those living colonies, the adults cannot digest solid food well, so they hunt prey for their larvae and then chew on the larvae to drink their fluids, a grisly practice called non-destructive cannibalism. The hell ants may have run a similar household, the bizarre adults serving as armored hunters for a colony they could barely feed themselves from. Strange jaws, a metal horn, a sting, and a family life built on drinking the blood of their own young. Hell ants thrived for roughly 20 million years across what is now Asia, Europe, and North America. And then, around the time the dinosaurs died, every single one of them vanished, leaving no descendants. An ant that bit upward, wore a metal horn on its head, and drank blood is exactly the kind of animal that sounds invented.
It was not. It was sealed in amber mid-strike 99 million years ago. Number 6. The Tully monster. The creature nobody can classify. In 1958, an amateur fossil collector named Francis Tully was splitting open ironstone nodules in a coal mining area south of Chicago, in a place called Maison Creek, when he found something he could not identify, and neither could anyone at the museum he brought it to. More than 60 years later, we still cannot. The animal is officially called Tullymonstrum gregarium, after its discoverer, but everyone just calls it the Tully monster, and it is the state fossil of Illinois. It is also one of the single most baffling animals in the entire fossil record. The creature lived about 309 million years ago, in the Carboniferous, in what was then a warm coastal estuary where rivers met the sea. We have thousands of specimens, all from that one location, so it is not rare and it is not poorly preserved.
The problem is its body, which seems assembled from spare parts. It was soft and segmented, roughly the length of your hand, shaped like a swimming torpedo. Its eyes sat at the ends of a long, rigid bar that stuck straight out sideways from its body, like the eye stalks of a hammerhead pushed to a ridiculous extreme. And reaching out from the front was a long, thin, flexible snout, a kind of proboscis, ending not in a mouth, but in a small claw lined with little teeth. Eyes on a bar, a clawed feeding arm for a nose, a soft, segmented body. The question that has consumed scientists for decades is brutally basic. What is it? Is it even a vertebrate, an animal with a backbone, like us? Or is it an invertebrate, like a worm or a snail? In 2016, a major study in Nature argued it was a vertebrate, a relative of lampreys, claiming to find traces of a primitive backbone. The case seems strong.
Then in 2023, another team used high-resolution three-dimensional laser scanning on more than 100 specimens and concluded the opposite, that the features did not match a vertebrate at all. As things stand, after 65 years, science genuinely cannot agree which of the two great branches of animal life this creature belongs to. The place that produced the Tully monster is as unusual as the animal. Mazon Creek is a deposit where soft-bodied creatures were sealed inside hard nodules of ironstone, each one a little stone capsule that, when cracked open, can reveal the ghost of a jellyfish, a worm, or a shrimp that would normally have vanished without a trace. Because of this, Mazon Creek preserves an entire soft-bodied community from 300 million years ago, and the Tully monster is its undisputed star. Common enough there that its species name, gregarium, simply means it occurs in numbers. After Francis Tully brought his find to Chicago's Field Museum and stumped the experts, the creature gradually became a local icon. And in 1989, the state of Illinois named it its official state fossil, an honor it now holds while remaining scientifically unidentifiable. The back and forth over what it is has become one of the great running arguments in paleontology. The 2016 study that called it a vertebrate pointed to what looked like a stiffening rod along its body, the traces of gills, and even the structure of its preserved eyes, which seem to contain the same kind of light-sensing pigment granules found in animals with backbones. For a while, the lamprey relative idea seemed to be winning, but critics kept finding problems. The teeth did not sit the way a lamprey's do. The supposed backbone could be read other ways, and the latest three-dimensional scanning work pushed back hard toward the conclusion that the body simply is not built like a vertebrate's. After more than 60 years and some of the best techniques modern science can throw at it, the honest answer to the question, what is the Tully monster, remains. Nobody is sure. Part of why the Tully monster resists classification is that it has no living analog whatsoever. With most fossils, even strange ones, scientists can find some modern animal that shares a key feature and reason outward from there. The Tully monster offers no such handhold. Nothing alive today has eyes mounted on a rigid horizontal bar combined with a long, clawed feeding snout on a soft, segmented body. There is also the problem that it is known only from this single locality. If Mazon Creek had never formed its peculiar stone capsules, we would have no idea the animal had ever existed at all. And there are surely other creatures just as strange that left no trace, because the conditions to preserve them never occurred. Even the animal's eyes have been pulled into the fight. One study found that they contained the same kind of pigment structures seen in vertebrate eyes, which seemed to settle the matter, until further analysis showed those structures are not unique to backboned animals after all. Every apparent answer has dissolved into a new argument. Mazon Creek actually preserves two neighboring worlds, a marine community where the Tully monster lived, and a nearby freshwater and land community full of early insects, plants, and amphibian relatives.
Together, they make the site one of the most complete snapshots of life from this entire period, which only sharpens the irony that its most famous resident remains a riddle. The Tully monster became such a local point of pride that when Illinois decided to choose a state fossil in the 1980s, school children across the state campaigned and voted for it, enshrining as an official emblem an animal that science still cannot confidently assign to a phylum. Few places have ever honored their own ignorance so cheerfully, or so deservedly, because the mystery is genuinely part of the charm. That is what earns the Tully monster its place. Most strange animals are at least classifiable. We can say what kind of thing they are, even if they look bizarre. The Tully monster resists even that. It is an animal we can hold in our hands by the thousand and still not place on the tree of life. The next creature is the opposite kind of mystery. It looks almost ordinary, a little deer-like animal by the water, until you learn what its descendants became. Number 5. INDOHYUS, the tiny deer that became the whale. Some animals look impossible because of how they are built. This one looks impossible because of what it turned into. Around 48 million years ago, in what is now Kashmir in the Himalayas, there lived a small hoofed animal called INDOHYUS, about the size of a raccoon or a small cat, slender-legged, with a long tail and a delicate body. If you saw it stepping through the shallows, you would think of a miniature deer, or one of the tiny chevrotains, the mouse deer, that still live in the forests of Asia today. It looks utterly unremarkable. It is, in fact, one of the most important fossils ever found, because INDOHYUS is the closest known relative of whales. Let that sink in. The blue whale, the largest animal that has ever existed on this planet, larger than any dinosaur, traces its family line back to a creature you could have held in your two hands. And the fossils show exactly how that impossible journey began. When paleontologist Hans Thewissen and his team studied INDOHYUS in 2007, publishing in Nature, they found two telltale clues hidden in its little skeleton. First, its bones were strangely thick and dense, a condition called osteosclerosis. Light-boned animals float, heavy-boned animals sink. This kind of dense skeleton is exactly what you find in animals that wade and walk along the bottom of rivers and shallows, like the hippopotamus, using their own weight as ballast. INDOHYUS was spending its life in and around the water. The second clue was decisive. In the ear of INDOHYUS was a specific structure, a thickened, bony wall of the middle ear called the involucrum.
That structure is found in exactly one group of animals in the entire history of life: whales and their direct ancestors. No other creature has it. Finding it in this tiny deer-like animal was like finding a family fingerprint. It confirmed that this little waterside creature sat right at the base of the whale family tree. INDOHYUS is the final piece in what has become one of the best documented evolutionary transitions in the entire fossil record: the journey of whales from land to sea. Over the last few decades, paleontologists have lined up a remarkable series of fossils that trace the change step by step. There is Pakicetus, a wolf-sized animal with whale-like ears but 4 working legs. There is Ambulocetus, the walking whale, a crocodile-shaped amphibious hunter. And reaching back behind all of them sits little INDOHYUS, showing that the story did not begin with a hunter at all, but with a small, timid plant eater waiting in the shallows.
Genetics later confirmed the surprising punchline of this whole story. The closest living relatives of whales are the even-toed hoofed mammals, and in particular, the hippopotamus. The whale's family reunion includes deer, pigs, and camels. The behavior that started it all may still be visible today. There is a living animal, the water chevrotain of Africa, a tiny deer-like creature that, when threatened by a predator, runs into a river and submerges itself, walking along the bottom and staying under until the danger passes. Many researchers think INDOHYUS did something similar, using the water as a refuge rather than a hunting ground, since its teeth show it was eating plants, not fish. That detail reverses the order you might expect. These animals did not enter the water to chase new prey. They entered it to hide, and only much later did their descendants begin to feed there, and then to live there entirely.
The most colossal predators the oceans have ever known began with a frightened vegetarian holding its breath in a stream. The timing of the whole transformation is what makes it so staggering. The earliest of these waiting ancestors lived around 50 million years ago. By roughly 40 million years ago, fully aquatic whales were already swimming in the open ocean, their legs reduced to useless stumps. In the span of about 10 million years, a sliver of time in geological terms, a small 4-legged land animal was remodeled into a creature of the deep sea, its nostrils marching up its skull to form a blowhole, its body ballooning, its forelimbs flattening into flippers, and its hind limbs all but disappearing. We can read nearly every chapter of that change in the rocks, which is why this sequence is so prized. It is one of the clearest, most complete examples of a major evolutionary transformation we possess. And it all rests on the slender shoulders of INDOHYUS, the little waterside animal that proved the giants of the sea began as a timid grazer, no bigger than a cat. The INDOHYUS story turned on a single bone in the ear, and the moment of recognition has become a small legend in paleontology. Hans Thuisen had been searching for the land ancestors of whales for years when a student accidentally broke open a skull of this obscure little Asian animal, exposing the inner ear. And there it was, the involucrum, the dense, bony shelf that had until then been considered a feature of whales and nothing else. A creature that looked for all the world like a tiny deer was wearing the unmistakable badge of the whale family. INDOHYUS belongs to a small group called rheoelids, plant-eating waders that branched off right at the base of the whale lineage, and its discovery slotted the final, earliest piece into the puzzle of how the largest animals on the planet got their start. The picture that emerges is extraordinary. The ancestors of whales did not start as sea monsters. They started as small, shy, deer-like land animals that waded into rivers, probably to hide from predators, the way the modern water chevrotain dives underwater to escape a hawk. From that habit, over tens of millions of years, came everything. Bodies that lengthened, legs that turned to flippers, nostrils that migrated to the top of the head to become a blowhole, and ultimately, the largest creatures the oceans have ever held. INDOHYUS should not exist, in the sense that nothing about this fragile little animal hints at what its descendants would become. It is the whale before the whale. Number 4. PALAEOPHONUS, the scorpion that breathed underwater. Think of a scorpion and you think of the desert. Dry sand, baking rock, an armored hunter built for the harshest land on Earth.
So consider a creature that should not exist by that definition alone. A scorpion that lived in the sea and breathed water. Around 430 million years ago, in the Silurian period, long before any animal with a backbone had crawled onto land, the first scorpions appear in the fossil record. One of the earliest to be named was PALAEOPHONUS, found in the ancient marine rocks of Gotland in Sweden, and soon after in Scotland. And the deep puzzle of these animals is that the earliest scorpions may not have been land animals at all. The evidence is genuinely divided, and the argument has run for over a century. Some of these oldest scorpions are preserved in clearly marine rock, alongside sea creatures, in deposits laid down underwater. Their anatomy in places points the same way. Modern scorpions breathe air using internal structures called book lungs, stacks of thin tissue folded like the pages of a book.
But their marine cousins, the horseshoe crabs, use a similar-looking structure to breathe water instead, book gills. And the earliest scorpions appear to sit right on that boundary, with respiratory and other features that look adapted for water rather than air. Many researchers now think the first scorpions were aquatic, breathing through gills, hunting in Silurian seas and lagoons, with the fully land-living, air-breathing scorpion coming later. A discovery in 2020 made this even clearer. In the rocks of Wisconsin, scientists found one of the oldest scorpions yet, around 437 million years old, and it was preserved so well that the internal anatomy survived, the circulatory and respiratory systems fossilized inside the body. What they saw was an animal that looked internally almost exactly like a modern scorpion, but that still carried features shared with its marine relatives.
It was a creature caught in the very act of straddling two worlds, water and land, at the threshold of one of the most important transitions in the history of life, the moment animals began to leave the ocean. For more than a century, these earliest scorpions were tangled up in one of the biggest questions in the history of life. When and how did animals first crawl out of the water and onto dry land? Scorpions were long treated as candidates for the very first land animals, pioneers that left the sea to exploit an empty world. But the deeper researchers looked, the more the picture blurred. The respiratory question sits at the heart of it. A book lung for breathing air and a book gill for breathing water are built on the same basic plan, stacks of thin plates, and it is not always possible to tell from a flattened fossil which one an ancient scorpion actually had. An animal could look almost modern and still have been breathing water.
The seas these creatures lived in were also home to their monstrous relatives, the Eurypterids, or sea scorpions, some of which grew to over 2 meters long and ranked among the top predators of their age. True scorpions were the small cousins of that lineage, and the question of which one stayed in the water and which ventured out has never been fully settled. The exceptionally preserved Wisconsin fossil from 2020, with its internal organs intact, was hailed as a major clue, though even its identification as a scorpion has been debated since. What is clear is that the boundary between sea and land, which feels so absolute to us, was once a blurry frontier that animals crossed slowly, over millions of years, and the early scorpions were right there on the threshold, stingers raised, breathing who knows what, feeling their way toward a world no animal had yet claimed. It also helps to remember what else shared these Silurian waters, because it puts the humble scorpion in context. The same seas were ruled by the Eurypterids, the sea scorpions, distant relatives that included monsters like Jacalopterus, which grew to over 2.5 meters and was among the largest arthropods that has ever lived. Against that backdrop, the first true scorpions were modest creatures, but they were attempting something the giant sea scorpions never managed, a permanent move onto land. They were not entirely first in that race. Small creatures like early millipedes were also testing the air around the same time. But the scorpion's journey is special precisely because the animal is still with us, almost unchanged in basic plan, so that when you see a scorpion today, you are looking at the descendant of one of the original pioneers, a body design that worked so well at the threshold of land that it has barely needed updating in over 400 million years. So PALAEOPHONUS and its kin are not really a mistake. They are a glimpse of an almost unbelievable truth. The scorpion, that ultimate symbol of the bone-dry desert, very likely began its story in the sea, breathing through gills. The deadliest icon of dry land may have started out underwater. Number 3. STRASHILA, the insect that fooled everyone. In the late Jurassic, around 165 million years ago, in what is now Siberia, there lived an insect so peculiar that its discoverer named it after the Russian word for a fright, a scarecrow. The full name is Strashila incredibilis, the incredible scarecrow, and it is barely 7 millimeters long, a speck of an animal. But few tiny fossils have caused as much confusion, because for 2 decades, science had its entire way of life completely wrong, in the most dramatic way possible. When the paleontologist Alexander Rasnitsyn first described Strashila in 1992, he was confronted with a bizarre little body. A wingless insect with strange, piercing mouthparts, a flexible abdomen bearing odd fleshy tubes, and a pair of grotesquely enlarged clawed hind legs that looked built for grabbing and holding on. He drew a striking conclusion. This, he proposed, was a blood-sucking parasite, and not just any parasite. He suggested it lived on the bodies of pterosaurs, the flying reptiles of the Mesozoic sky, clinging to the leathery membranes of their wings with those grappling hook legs and drinking their blood, a tiny vampire riding the dragons of the Jurassic. It was a vivid, unforgettable image, and it was wrong. The truth came in 2013, when scientists led by Huangdi Ying published a reanalysis in Nature based on many new and better preserved fossils, and the real Strashila turned out to be stranger than the vampire story. It was not a parasite at all. It was an amphibious insect, a relative of certain modern aquatic flies that lived in and around fresh water. The new fossils revealed that both males and females actually had wings, but that they were deciduous, designed to be shed. The insect would fly, mate, and then snap its own wings off to live out the rest of its life in the water, laying its eggs there. And those enormous grappling hook hind legs, the ones thought to grip pterosaur skin, belonged only to the males. They were not for holding on to a host at all. They were for holding on to a female during mating. Sit for a moment with how confident and how wrong the original idea was. When Rasnitsin examined the single tiny specimen, the pieces seemed to fit a gruesome picture. The strange mouth parts looked built for piercing. The enlarged, clawed hind legs looked built for gripping.
And the Mesozoic skies were full of pterosaurs, with leathery wing membranes, the perfect host for a clinging blood drinker. He even erected a whole new order of insects to contain this bizarre creature, and a similar one called Saurophtyrus, whose name literally means lizard louse. For 20 years, the pterosaur-riding vampire was the textbook story, a vivid little piece of Jurassic horror. The unraveling shows how much a single, well-preserved fossil can change. When Huang Diying's team examined new specimens, including a second species from the famous Daohugo beds of China, the grasping legs turned out to belong only to males. The wings turned out to be present in both sexes and built to break away, and the whole animal turned out to be a relative of the nymphomyids, a family of minuscule aquatic flies that survive today and that famously shed their wings to live and breed in water. The lurid parasite dissolved into something subtler and, in its own way, more remarkable.
There is even an ongoing debate about whether the order Rasnitsin created should exist at all. Strashila is a lesson, written in 7 millimeters of stone, in how easily a strange enough animal can lead even careful scientists to imagine a creature that was never really there. The deeper lesson of Strashila is about how science handles a sample of one. For 2 decades, nearly everything believed about this insect rested on a single, partly damaged specimen, interpreted as best anyone could. With so little to go on, a confident, vivid story filled the gap, and because it was the only story available, it hardened into fact and spread into popular accounts. It took a flush of new, better-preserved fossils to dislodge it, and even the replacement is still debated at the edges.
The modern relatives that finally made sense of it, the nymphomyids, are themselves almost absurdly obscure. Among the tiniest of all flies, they live as adults for only a brief window, barely feeding, existing mainly to mate and lay eggs in cold, clean water before they die. Strashila, it seems, was running a version of that same fleeting, water-bound life cycle in the Jurassic, 160 million years ago, shedding its wings to finish the only job that mattered. So the real Strashila is an insect that flew, found a mate, clamped on with specialized grappling legs, discarded its own wings, and dropped into the water to start the next generation. It was never a vampire on a flying reptile. It was something arguably weirder. A creature whose strangeness was so extreme that the first scientists to see it invented an entire lurid lifestyle to explain it.
The next animal, though, really was a blood drinker. It really was a giant, and it may have survived almost to the present day. Number 2, Desmodus draculae, the giant vampire that nearly reached our time. Vampire bats are real, and they are small. The common vampire bat alive today is a modest little animal, barely larger than a mouse, that laps a teaspoon of blood from sleeping cattle and flies off into the night. Now, make it 30% bigger, give it a wingspan of half a meter, and set it loose in a world full of giants. That animal existed. It is called Desmodus draculae, the giant vampire bat, named directly for Count Dracula, and it is the largest blood-feeding bat that has ever lived. Desmodus draculae hunted across Central and South America through the Ice Age, and its prey was as large as its appetite. This was a time when the continent teemed with megafauna, giant ground sloths the size of cars, armored glyptodonts, huge hoofed grazers. The giant vampire bat fed on their blood, settling onto these enormous animals in the dark and opening their skin with its blades of teeth. In one remarkable find, paleontologists recovered a jawbone of Desmodus draculae from inside the fossilized burrow of a giant ground sloth, the bat quite literally found in the lair of a creature it may have been feeding on. A bigger body let it take bigger meals, and the Ice Age laid out a banquet of them. But the most unsettling thing about this animal is not its size. It is how recently it may have been alive. Most of its remains date to the Pleistocene, the Ice Age proper, but some are far younger. A canine tooth found in sediments in Argentina has been dated to roughly 300 years ago, around the year 1650, and some researchers have suggested the species may have survived into colonial times, perhaps into the early 1800s. Some of its remains are barely fossilized at all.
This raises the genuine possibility that a giant vampire bat was still flying over South America when European ships were already crossing the Atlantic, and that it slipped into extinction so recently we almost caught it. It may even live on in legend, in the bat gods and monstrous flying creatures recorded in the myths of the region's peoples. To picture how this animal lived, it helps to know how vampire bats actually feed, because the reality is stranger than the myth. A vampire bat does not suck blood through fangs. It uses heat sensors in its face to find a spot where blood flows close to the skin, makes a tiny, painless cut with razor-edged teeth, and laps at the wound, which keeps flowing because the bat's saliva contains a powerful anticoagulant that stops the blood from clotting. They are also intensely social animals that share meals, regurgitating blood to roostmates who failed to feed.
Now scale all of that up by a third and turn it loose on animals the size of cars, and you have Desmodus draculae, opening the skin of a giant ground sloth in the dark and drinking its fill. What killed it is a genuine mystery, and the leading idea ties its fate to the disappearance of those giants. As the Ice Age ended and the great megafauna of the Americas died out, the giant vampire bat may have lost the large-bodied prey its size depended on, unable to make a living on smaller animals the way its little cousin still does. The Argentine jawbone that pushed its survival toward historical times was found, remarkably, inside the burrow of a giant ground sloth, dated to around 100,000 years old. But other scraps are so fresh and so lightly fossilized that some researchers place its final extinction within the last few centuries, perhaps nudged over the edge by the cold snap known as the Little Ice Age.
It may even survive in human memory. Some have linked it to Camazotz, the death bat god of Maya myth, and to monstrous bats described in the oral traditions of peoples across its old range. There is a strange modern footnote to this ancient animal, and it brings the story uncomfortably close to home. The anticoagulant in vampire bat saliva is so effective at keeping blood flowing that medical researchers have studied it intently, developing compounds based on it that have been investigated as clot-busting drugs for human stroke patients. The very chemistry that let a giant vampire feast on an Ice Age sloth may one day help save a human life. And humans almost certainly knew this animal directly. The first people to spread through the Americas, more than 10,000 years ago, lived alongside Desmodus draculae and the megafauna it fed on.
If the youngest dates are right, the species may have lingered in remote caves long after, which raises the eerie possibility that some of the bat monsters woven into the myths of the continent were not pure invention, but blurred memories of a real giant that still occasionally flew out of the dark. To grasp its scale, set it beside the bat in your garden. The paleontologist who described the largest known jaw of Desmodus draculae remarked that the animal was larger than a computer keyboard, where the common vampire bat alive today could sit comfortably inside a teacup. Its remains have surfaced across at least 7 modern countries, from Mexico down through Belize, Venezuela, Ecuador, Brazil, and Bolivia, all the way to Argentina, which tells us this was no rare local oddity, but a widespread and successful predator across a whole continent. For tens of thousands of years, a vampire with a half-meter wingspan was a normal part of the South American night, settling silently onto the largest animals of the age and drinking until it was full. A blood-drinking bat the size of a small hawk, feeding on Ice Age giants, perhaps still on the wing when the first ships reached the New World, is exactly the kind of creature that feels like folklore. But it left its teeth in the caves of a continent, and it was as real as the bats outside your window tonight. Which leaves number 1. It is the smallest creature on this entire list, and the only one whose single tiny body holds, all at once, the whole impossible paradox we have been circling. Number 1. ATTERCOPUS, the spider that came before the web. Around 386 million years ago, in the Devonian period, in the rocks of Gilboa in New York State, there lived a tiny arachnid barely a centimeter long. When its fossils were studied in the late 1980s, scientists believed they had found something momentous: the oldest spider in the world. The little creature appeared to have the two defining features of a true spider. It seemed to have spinnerets, the specialized organs spiders use to spin silk into webs, and it seemed to have a venom-delivering fang. It was named, with a nod to Old English folklore, after the word attercop, meaning spider, a word J.R.R. Tolkien later put in the mouth of Bilbo Baggins to taunt the giant spiders of Mirkwood. For years, ATTERCOPUS was the first spider, the founder of a line that would spin webs across the whole world. And then, on closer inspection, it fell apart in the most fascinating way. A detailed restudy, led by Paul Selden and published in 2008, took the fossils apart feature by feature, and almost everything that had made ATTERCOPUS a spider turned out to be a misreading.
The fang's venom opening was a misinterpretation. And the spinnerets, the crucial silk-spinning organs, were not spinnerets at all. What looked like a tubular spinneret was actually a folded sheet of cuticle, flattened in the rock. ATTERCOPUS could produce silk. That part was real, oozing it from a series of small openings called spigots. But those spigots were arranged in flat rows on plates on the underside of its abdomen, fixed in place. It had no true spinnerets, no mobile, finger-like organs to draw out and weave the thread. Which means that ATTERCOPUS, this maker of silk, could not spin a web. It physically lacked the equipment. There was one more revelation, and it is the strangest of all. ATTERCOPUS had a tail. Extending from the back of its body was a thin, segmented flagellum, a whip-like tail of the kind you see today on the small arachnids called whip scorpions. No living spider has anything like it. So this creature was not a spider at all in the end. It belongs to an extinct order, the Uraranaida, the near spiders, animals that stood just outside the spider line, able to make silk, but unable to spin it into a web. And still carrying an ancient tail their true spider descendants would eventually lose. Astonishingly, the combination lingered for hundreds of millions of years. A creature found in amber in 2018 still had both silk-spinning spinnerets and a tail at the same time. The ground that held ATTERCOPUS is almost as remarkable as the animal. Gilboa, in New York State, preserves one of the oldest known land ecosystems on Earth, from a time when life was only just gaining a foothold on the continents. Nearby are the stumps of what are considered among the planet's oldest forests.
When William Shear and Paul Selden first reported silk-producing structures from this site in the late 1980s, the claim was a double headline. Not only the oldest spider, but the oldest evidence of silk, one of the most important materials any animal has ever produced. That is why the reinterpretation landed so hard. Stripping ATTERCOPUS of its spinnerets did not just demote one fossil. It rewrote the timeline of when the web, that defining spider technology actually appeared. The tailed near spiders turned out to have a long and stubborn history. ATTERCOPUS had a Permian cousin, Permarachne, that also made silk and kept its tail. And then, astonishingly, a creature called Chimerarachne was found in Burmese amber in 2018, only about 100 million years old, that still had both spinnerets and a tail at the same time, meaning these tailed silk makers survived for 250 million years longer than anyone had guessed. As for the silk itself, without spinnerets to weave it, the earliest uses must have been simpler than a web. Wrapping eggs to protect them, lining a burrow, or trailing a single safety line. The orb web, the engineered net we picture when we think of a spider, would not be perfected until tens of millions of years after ATTERCOPUS was gone. The web, in other words, was one of evolution's later inventions, and the silk came first, in the body of an animal that could not yet weave it. The picture grows richer with each related fossil scientists uncover. In 2016, researchers described another ancient arachnid called Idmonarachne, which, unlike ATTERCOPUS, had already lost its tail but still lacked true spinnerets, catching evolution at yet another intermediate step between the near spiders and the real thing.
Strung together, these fossils show that becoming a spider was not a single leap, but a long, piecemeal assembly. First silk, then the loss of the tail, then, much later, the mobile spinnerets that finally made weaving possible. The name we gave this little pioneer fits its in-between nature perfectly. Attercop is an old word meaning poison head, an insult for spiders that lingered in the dialects of northern England, and that Tolkien revived in The Hobbit, when Bilbo sings it to taunt the giant spiders of Mirkwood. We named the first thing on the road to spiders after an old curse for the creatures it would one day become, a fitting label for an animal that was almost, but not quite, a spider at all. It is worth stating plainly just how late the web arrived, because it reframes the whole image of what a spider is. The familiar orb web, the wheel of sticky silk strung between branches, was not perfected until long after ATTERCOPUS, evolving with the more advanced spiders many tens of millions of years later, and some of the silk spinning techniques behind it are younger still. For an enormous stretch of arachnid history, then, there were silk makers but no webs, animals carrying the raw material of the greatest trap in the natural world with no way to build the trap itself. ATTERCOPUS sits at the very beginning of that long road, a creature that had already invented the thread but would never see the snare, separated from the first true web by an ocean of time it did not live to cross. Think about what ATTERCOPUS tells us. It means that silk is older than the web. Before any animal ever spun a snare to catch prey, creatures like this were already producing silk for something simpler: to wrap their eggs, to line their burrows, to lay down a guideline as they walked. The web, that miracle of natural engineering, would not be invented for tens of millions of years more. ATTERCOPUS is a creature caught in the middle of becoming something else. A spider that was not yet a spider, holding a technology it did not yet know how to use, wearing a tail it had not yet shed. By every expectation we have of what a spider is, it should not exist. And yet, it is exactly where every spider on Earth comes from. Finale. 10 creatures that, by every rule we thought we knew, should never have existed. An armored worm with a face nobody could find. A mammal that ate dinosaurs. A swimmer with 5 eyes and a hose for a mouth. An ant that bit upward and drank blood. An animal we cannot even classify. A deer that became a whale. A scorpion that breathed water. An insect that shed its own wings. A vampire that nearly reached our century. And a spider that could not spin a web. But here is the thing worth carrying away from all of them. None of these creatures was actually a mistake. They look impossible only because we expect evolution to aim straight for the animals we already know,
and it never does. Evolution does not plan. It experiments endlessly in every direction at once, and most of its experiments are dead ends. HALLUCIGENIA and OPABINIA were early rough drafts of the body plan that would one day produce every insect and spider. The water-breathing scorpion was life-testing the very idea of leaving the sea. INDOHYUS was the whale before there was an ocean to swim in. ATTERCOPUS was the spider before there was a web to spin. They are not failures. They are evolution thinking out loud, and a few of those strange experimental whispers led eventually to the crab, the spider, the whale, and to us. Which leaves one last, slightly uncomfortable thought. If these animals should not have existed, then neither should we.
The line that leads to human beings is built from exactly the same kind of improbable, fragile, experimental creatures. Drafts that happened to survive when 1,000 others did not. Every one of these impossible animals is a reminder that life is not a tidy march toward us. It is a vast, branching, reckless sprawl of attempts, and we are simply one of the experiments that worked. There is one more pattern hiding in these 10 stories, and it is not about the animals. It is about us. Look at how many of them we got wrong. We put HALLUCIGENIA upside down and backwards. We laughed OPABINIA out of the room. We crowned ATTERCOPUS the first spider and the TULLY monster a vertebrate, and then took both titles away. We invented a pterosaur-riding vampire that never existed. Again and again, these creatures did not just break the rules of biology. They broke our confidence that we already understood the past. The fossil record is not only a record of life, it is a record of our own surprise, and of how often the truth turned out to be stranger than the strangest thing we first imagined. And there is a quieter thread running through all of it, beyond our mistakes. Nearly every one of these animals sat at a threshold. HALLUCIGENIA and OPABINIA stood at the dawn of complex animal life, when the basic body plans were still being drafted. The early scorpion crouched at the edge of the water, at the threshold of land itself. INDOHYUS waited at the boundary between land and sea that its descendants would erase. ATTERCOPUS held silk at the threshold of the web. These were not creatures stuck in the middle of nowhere.
They were creatures caught in the middle of becoming, frozen at the exact moments when life was reaching for something it had never been before. If this rewired how you think about what life is capable of, subscribe, because there are far stranger things still waiting in the rock. And tell me in the comments, out of all 10, which one are you most convinced should never have existed? Until next time.